Hey everyone, welcome back. Today we're going to be doing a deep dive into a research paper that really caught my eye. It's about the security and privacy of machine learning.
Yeah.
And honestly, some of the findings are kind of unsettling.
Oh, yeah.
Like it turns out those algorithms that we rely on every day, they might be more vulnerable than we think.
That's right. And what's really interesting about this paper is that uh, it doesn't just focus on the vulnerabilities. It explores the emerging defenses too.
Okay.
The ongoing battle between attackers and defenders in the machine learning landscape.
So before we jump into the really technical stuff, I think it's important to kind of set the stage here.
Go.
We all know that machine learning is everywhere these days, but for this deep dive, we're primarily focusing on supervised learning,
Right.
specifically classification tasks.
Okay.
Like think of things like spam filters that are sorting emails or systems that flag fraudulent transactions.
Exactly. And
Yeah.
and this is where a lot of the security research has been focused because these classification systems, they're often making really critical decisions that impact our lives in really significant ways.
Absolutely.
Yeah.
So let's imagine we have this model that's trained to spot malware,
Okay.
right? It's been fed tons of examples and can theoretically tell a good app from a bad one.
Yeah.
Now, where do the vulnerabilities come in? This paper kind of breaks down the machine learning process into like a pipeline, which I found really helpful for understanding like where you can attack it.
The pipeline analogy is really key here.
Yeah.
You start with data collection. You're gathering all those, software samples.
Right.
Then comes the training phase,
Right.
where the model learns from the data. And finally, there's the inference stage, where it puts that knowledge to work, analyzing new software.
Okay.
And what's interesting is that each stage, it presents its own unique security challenges.
So starting with data collection. Yeah.
It seems like there's potential for things to go wrong right out of the gate.
Absolutely. I mean, think about it. What if someone tampered with the software samples before they were even used to train the model?
Yeah.
This is where something called poisoning attacks comes into play.
Okay.
An attacker could slip in cleverly disguised malware, malware that the model then learns to trust. It's like subtly corrupting the textbook before the student even starts learning.
Wow. That's kind of scary.
Yeah.
I mean, we're essentially talking about like manipulating the foundation of the whole system.
Precisely. And
Yeah.
and the implications can be serious. I mean, especially as these systems become more and more integrated into critical infrastructure.
Yeah.
Imagine an autonomous vehicle being trained on a data set where the stop signs have been subtly altered.
Right. Right.
Yeah.
So we've got these poisoning attacks at the data collection stage. What about during the training process itself?
Right.
Are there vulnerabilities there? Definitely. Even if the data collection is secure, attackers can still target the training phase. One common technique is something called label manipulation,
Okay.
where they change the labels of the training data,
Yeah.
to mislead the model. So, for example, instead of labeling a picture of a cat as cat, they might label it as dog.
So it's kind of like messing with the answer key.
Yeah, and it can be incredibly effective, especially with online learning systems.
Right.
These systems, they're constantly being updated with new data.
Mm-hmm.
So an attacker could continuously feed them malicious data with manipulated labels, and it gradually skews the model's understanding.
And I imagine this kind of attack is especially difficult to detect because it's happening under the hood, during the learning process itself.
Exactly. It's a subtle form of manipulation that can have a significant impact on the model's accuracy and reliability. And this brings us to the third stage of the pipeline, inference. This is where the model is actually making decisions based on what it's learned.
Right. So the model is out in the wild now,
Yeah.
making judgments about new software. What kind of attacks are possible at this stage?
This is where things get really interesting. Imagine someone creates a seemingly harmless app, but with tiny little tweaks designed to fool the model,
Okay.
to make it think that it's benign.
Uh-huh.
These are known as adversarial examples.
So they're crafting inputs designed to exploit the model's weaknesses.
Exactly. And what's fascinating is that these adversarial examples, they can be incredibly subtle, often imperceptible to humans.
Oh, wow.
For instance, researchers have shown that by making tiny, carefully crafted perturbations to an image, you can completely fool a state-of-the-art image recognition system.
So even if a model has been trained on a massive data set and it seems incredibly accurate, it can still be tricked by these like almost invisible manipulations.
That's the
Yeah.
challenge with adversarial examples. They highlight how machine learning models can be fooled by inputs that deviate even slightly from what they've been trained on.
Yeah.
And this is where the distinction between what we call white box and black box attackers comes into play.
Right. I remember we touched on that earlier. So a white box attacker has full knowledge of the model's inner workings.
Mm-hmm.
Right, like the
Yeah,
specific algorithms and parameters.
precisely.
Whereas a black box attacker only has access to the model's inputs and outputs.
That's right. So a white box attacker can leverage their knowledge to craft highly targeted adversarial examples,
Right.
to exploit specific vulnerabilities in the model's design.
Right.
But even black box attackers can be surprisingly effective.
Really? How so? If they don't know the model's internals, how can they craft these adversarial examples?
They use something called oracle attacks.
Okay.
It's a bit like a game of 20 questions. They feed the model a series of inputs, and they observe the outputs, and they gradually learn about its decision boundaries, its vulnerabilities, and then they can use that knowledge to craft adversarial examples that are likely to fool the model.
So even if you protect your model's code, and keep its inner working secret, it's still susceptible to attacks that exploit its external behavior.
Right.
That's a little unsettling, to be
Yeah.
honest. It feels like there's always a way, for a determined attacker to find a way in.
That's a valid concern, and it's one of the reasons why research in this area is so important.
Yeah.
I mean, the better we understand these vulnerabilities, the better equipped we are to develop effective defenses.
Okay. So we've got these different types of attackers, each with their own methods for exploiting machine learning systems. But what are their ultimate goals?
Right.
What are they trying to achieve by launching these attacks?
Well, they can target confidentiality and privacy,
Okay.
integrity and availability,
Okay.
or a combination of these.
Okay, let's break that down a bit. Confidentiality and privacy.
Yeah.
That's about protecting sensitive information, right?
Right.
Preventing an attacker from stealing the model itself or extracting personal data from the training data.
Exactly. Imagine a medical diagnosis system trained on patient data.
Okay.
An attacker might try to steal the model to use for their own purposes, or even extract sensitive patient information from it.
So the stakes can be pretty high here, especially when we're dealing with sensitive personal data. And what about integrity and availability? What do those goals look like?
So integrity, that's all about ensuring that that the model's outputs are reliable, that they haven't been tampered with.
Okay.
For example, an attacker could try to manipulate the input to a spam filter,
Right.
causing it to misclassify malicious emails as safe.
So they're essentially undermining the system's ability to function correctly.
Precisely.
Yeah.
And then there's availability,
Right.
which is about ensuring that the model is accessible and able to perform its intended function. So, for example, an attacker might try to overload a system with requests,
Yeah.
causing it to crash or become unresponsive.
Right. So it's not just about manipulating the model's outputs. It's also about disrupting its ability to operate at all.
Exactly.
Yeah.
And these goals can often be intertwined.
Yeah.
Attacker might target availability to disrupt a critical service, or they might target integrity to spread misinformation or cause financial harm.
This is all pretty mind-boggling. It seems like attackers have a lot of options when it comes to messing with machine learning systems.
Yeah.
And as these systems become more powerful, more and more integrated into our lives, I mean, the potential consequences of these attacks just become, more significant.
Absolutely. And that's why understanding these vulnerabilities and developing effective defenses is so crucial. I mean, it's an ongoing battle, and the stakes are only getting higher.
Okay, so now that we have a better understanding of the potential threats here,
Right.
let's shift gears and talk about defenses. What are researchers doing to make these machine learning systems more robust, more resilient to these attacks?
Well, there are several promising approaches being developed, and I think it would be helpful to delve into a few of them in more detail.
Okay.
But perhaps this is a good point to pause and pick up the conversation in the next part of our deep dive.
Sounds good to me. We've covered a lot of ground already, and I'm eager to learn more about how we can fight back against these attacks. So, join us next time as we continue our exploration of machine learning, security, and privacy. Welcome back. Last time we kind of left off talking about how these machine learning systems can be vulnerable to attacks. But it's not all doom and gloom, is it?
No, not at all.
There are researchers working hard to develop defenses to protect these systems, right?
Exactly. And there are some really innovative approaches being developed.
Okay.
One area that's particularly interesting is something called adversarial training. It's a bit like giving the model a crash course in self-defense.
Okay, that sounds intriguing.
Yeah.
So how does that work?
Essentially, you expose the model to both legitimate and adversarial examples
Okay.
during the training process.
Yeah.
So it's not just learning to recognize the good inputs, but also the bad ones,
Right.
the ones designed to trick it.
So it's like showing the model examples of both healthy cells and cancerous ones, so it can learn to distinguish between them more effectively.
Yeah, that's a good analogy.
Okay.
By being exposed to these adversarial examples, the model learns to be more resilient
Mm-hmm.
and less easily fooled by these subtle manipulations.
Makes sense. Are there any real world applications of this adversarial training that you find particularly interesting?
Yeah, one area where it's showing a lot of promise is in image recognition.
Okay.
For example, researchers have used adversarial training to develop systems that can more reliably detect objects in images,
Yeah.
even when those images have been, deliberately altered
Yeah.
to try to fool the system.
Right.
And this has huge implications
Yeah.
for everything from self-driving cars to medical imaging.
Right, because if a self-driving car can't reliably identify a stop sign, that could have disastrous consequences.
Hmm.
So adversarial training sounds like a really powerful tool for making these systems more robust. Are there any other defense strategies that you find promising?
Yeah, another approach that I find really fascinating is differential privacy.
Okay.
So it's a bit more complex, but essentially it involves adding carefully calibrated noise to the model's outputs.
Noise. Isn't the goal to make these systems as accurate as possible?
Yeah.
Wouldn't adding noise make them less accurate?
That's a good question.
Yeah.
It's true that adding noise does reduce accuracy to some extent,
Right.
but the key is that the noise is added in a very specific way that that preserves the overall utility of the model
Okay.
while also protecting the privacy of the data.
So it's like adding a layer of fuzziness that makes it harder for attackers to extract sensitive information.
Exactly. And the beauty of differential privacy is that it offers provable guarantees about the level of privacy protection being provided.
Okay.
So you can actually
Yep.
quantify
Yeah.
how much privacy you're getting,
Right.
which is crucial when dealing with sensitive personal data.
Absolutely. So we've got adversarial training to make models more robust
Hmm.
and differential privacy for protecting data privacy.
Right.
Are there any other aspects of security that we need to consider when it comes to machine learning?
Yeah, one area that's becoming increasingly important is fairness and accountability.
Okay.
It's not just about protecting these systems from attacks. It's also about ensuring that they're used ethically and responsibly.
Because these systems are making decisions that can have a real impact on people's lives.
Mm-hmm.
We need to make sure they're not perpetuating biases
Yes.
or discriminating against certain groups, right?
Exactly. So fairness in the machine learning is about ensuring that the model doesn't discriminate against certain individuals or groups.
Okay.
For example, a loan application model shouldn't unfairly deny loans to people based on their race or gender.
Mhm. And how can we ensure that these models are making fair decisions?
There are several approaches being developed. One is to carefully curate the training data
Okay.
to remove any biases that might be present.
Right.
Another is to incorporate fairness constraints
Uh-huh.
into the learning algorithms themselves,
Okay.
ensuring that the model doesn't learn to discriminate.
So it's like building ethical guidelines into the model's code.
In a way, yes.
Yeah.
It's about aligning the model's decision-making process with our societal values.
Right.
And this is where accountability comes in.
Okay, so how do we make these systems more accountable?
Accountability is about being able to understand and explain the model's decisions.
Okay.
Why did the model make a particular prediction?
Right.
What factors contributed to that decision?
Mm-hmm.
This is crucial for building trust in these systems.
Right, because if a system makes a decision that impacts someone's life, I mean, they have a right to know why that decision was made. But a lot of these machine learning models, especially the really complex ones, they can feel like black boxes.
Mm-hmm.
Like their internal workings are just hard to understand, even for experts.
That's true, and that's one of the big challenges in this field.
Yeah.
But researchers are developing techniques
Right.
to make these black boxes more transparent.
Mm-hmm.
One approach is to develop techniques to visualize the model's decision-making process, highlighting the factors that contributed to a particular prediction.
So it's like trying to peek inside the black box and see how the gears are turning.
Exactly.
Yeah.
And this is an area that's still evolving.
Right.
But the goal is to make these systems more interpretable and to give people more insight into how these decisions are being made.
This has been incredibly enlightening. It's clear that a lot of thought and effort is going into making these systems more secure, more private and fair. Mm-hmm.
But I'm curious, is there a fundamental limit to how secure we can make these systems?
Right.
Is there always going to be a trade-off between accuracy and robustness?
That's a great question, and it leads us to the concept of what we call a no free lunch theorem in adversarial learning. Essentially, it suggests that there's an inherent tension between model complexity, accuracy, and resilience to adversarial attacks.
So you can't have it all. You can't just crank up the complexity of the model and expect it to be both super accurate and super secure.
That's right.
Yeah.
More complex models have the potential to be more accurate and more robust.
Right.
But they also require more data to avoid what we call overfitting.
Okay.
And in the real world, we often have limited data available.
So finding the right balance between model complexity and data availability is crucial.
Exactly. It's about making strategic choices based on the specific requirements of the application.
And the potential threats that it faces.
It makes me wonder, with all these challenges, are we perhaps moving too quickly in our adoption of machine learning?
Mm-hmm.
Should we be more cautious given these potential vulnerabilities?
That's a really important question.
Yeah.
And one that deserves careful consideration. Machine learning has the potential to revolutionize countless aspects of our lives. Mm-hmm. But we need to be mindful of the risks involved.
Right.
It's not about halting progress, but about proceeding thoughtfully and responsibly.
I completely agree. We need to have open and honest conversations about these challenges and work together to develop solutions that prioritize security, privacy, and fairness.
Absolutely. And that brings us to a really crucial point.
Yeah.
This isn't just a technical challenge. It's a societal one.
Right.
We need to think about the ethical implications of these technologies and develop guidelines for their responsible use.
Right, because ultimately these systems are being designed to serve humanity. And we need to make sure they're doing so in a way that benefits everyone without compromising our safety or our values.
Well said. It's a collective responsibility that requires collaboration between researchers, policymakers, industry leaders, and the public.
And perhaps that's a good place to wrap up this part of our deep dive. We've covered a lot of ground, from specific attack techniques to emerging defenses and the ethical implications of this technology.
Indeed. It's been a fascinating exploration.
And for our listeners, don't go anywhere, because in our final part, we'll be tackling the big question: what does the future hold for machine learning, security, and privacy? Stay tuned. Welcome back to the final part of our deep dive into machine learning, security, and privacy.
It's been quite a journey, hasn't it?
Yeah, it really has. We've explored the vulnerabilities, the defenses. We even touched on some of the ethical dilemmas.
Yeah.
And now I think we're ready to tackle that big question that's been looming over this whole discussion.
You mean the future of machine learning, security, and privacy?
Exactly. I mean, machine learning is here to stay. It's already transforming so many aspects of our lives.
And it's only going to become more pervasive.
Right. which means the stakes are getting higher and higher when it comes to security and privacy. So where do we go from here? What can we do to ensure that these powerful technologies are used responsibly and ethically?
Well, I think one crucial aspect is fostering a culture of awareness.
Okay.
We need to make sure that everyone involved in the development and deployment of these systems understands the potential risks.
Right, because it's not just about having the technical expertise to build these systems, it's also about understanding the broader societal implications.
Exactly. We need to be thinking about questions of fairness, accountability, transparency from the very beginning,
Mm-hmm. Mm-hmm.
from the design process.
And that means bringing together diverse perspectives.
Yeah,
Right. I mean, we need ethicists, social scientists, legal experts, community members involved in the conversation,
absolutely.
not just engineers and data scientists.
It's a multidisciplinary challenge. It requires a holistic approach.
Hmm.
And I think education is another critical piece of the puzzle here.
You mean educating the public about how these systems work, the potential risks involved?
Yeah, but it's also about educating developers, policymakers, business leaders.
So that everyone understands their role in shaping a future where machine learning is used responsibly.
Precisely. We need to equip people with the knowledge and tools to make informed decisions.
It seemed like a daunting task.
Yeah,
But I'm also hopeful.
me too.
There's so much innovation happening in this field, not just in terms of new technologies, but also in terms of new ways of thinking about security and privacy.
That's true. We're seeing a growing awareness of these issues, and there's real momentum building towards developing more secure, private, and accountable machine learning systems.
And it's not just about mitigating risks, it's also about, realizing the incredible potential of this technology.
Right.
I mean, machine learning has the power to solve some of the world's most pressing problems,
Yeah.
from healthcare to climate change.
Absolutely.
But we can only unlock that potential if we build trust
Hmm.
in these systems. And that trust is built on a foundation of security, privacy, and fairness.
Well said. The future of machine learning is ultimately in our hands.
Yeah.
It's up to us to shape it in a way that benefits humanity as a whole.
And that's a pretty empowering thought, isn't it?
It certainly is. It's a challenge, but it's also an incredible opportunity. I'm excited to see where this journey takes us.
Me too. This deep dive has been a real eye-opener. I feel like I've learned so much, not just about the technical details, but also about the broader ethical and societal implications.
It's been a pleasure sharing this exploration with you.
And to all our listeners out there, thank you for joining us on this deep dive. We hope you found it as fascinating and thought-provoking as we did.
Remember, the future of AI is a story we're all writing together. So stay informed, stay engaged, and let's make it a future we can all be proud of.
Until next time, keep exploring and keep learning. This is The Deep Dive, signing off.